This is Captain Ross at 3B's Captain School, and this video is on weather as part of our deck video series. This is another video in our deck series. In this video, we're going to discuss weather. In this video, we want to identify characteristics of weather systems, state the tools used in weather prediction and observation, identify marine weather reports and charts, state how clouds can be used to predict weather, describe Bayes' ballot law and how it is used to predict low pressure centers. State which direction low pressure systems, especially large systems like hurricanes, spin in the northern hemisphere and why. All right, weather is one of the greatest hazards to vessels. Waves, sea state, visibility, lightning, and surf can present challenges to seamanship and survival skills. The operating area will provide its own unique weather characteristics. So there's basic differences in the weather characteristics if you operate in Key West versus Seattle. So you'll have to become familiar with your area and the normal weather patterns. On the East Coast, as an example, weather generally travels from the west to east. So you can kind of look at the weather that's going on west of the East Coast and get an idea of what the impending weather, over the next day or days or weeks are going to be on the East Coast. Cold fronts. So we'll talk about weather fronts. Cold fronts are the leading edge of a colder air mass. The steep slope of the cold air mass at the front forces warm air upward pretty rapidly. The resulting weather depends on the moisture content of the warm air mass. Normally, a zone of showers and thunderstorms, or a squall line, will likely form in a narrower and more intense zone than the precipitation band ahead of the warm front. So cold fronts, as they're approaching, they're usually preceded by a squall line. And these squall lines can have severe lightning, extremely heavy rainfall are all a possibility because that cold air is basically like wedging underneath that hot air and sending it up into the atmosphere. It can get pretty violent. After the cold front passes, the barometric pressure, atmospheric pressure, will increase. Cold air is more dense than warm air, so the pressure outside is going to increase and the temperature will drop. So this is if you look at a weather map, this is the symbol right here for a cold front. Warm fronts are the leading edge of warm air at the retreating edge of cold, more dense air. As the warm air mass rises above the colder air, it often condenses in a broad area of cloudiness. The warm surface air slowly replaces the colder air. So a warm front is a little bit different than a cold. A cold, as I described, it kind of wedges underneath that warm air because it's more dense. So it stays low, the warm air rises. When a warm front comes in, it kind of comes in over top of the cold air and then just kind of overtakes it. Depending on how warm that warm air is, will dictate how quickly it overtakes that cold front. So as a warm front passes, barometric or atmospheric pressure decreases and cloudiness increases. The way to remember this, cold air is more dense, heavier, more pressure. Usually better weather. Warm air, low pressure, because it's not as dense as cold air, and worsening weather. An occluded front occurs where a faster moving cold front overtakes and combines with a warm front. The weather patterns exhibited with an occluded front may include those characteristic of both warm and cold fronts, and cloud types may be mixed. So basically, an occluded front, you can have any range of weather, and I think it usually depends on which one of those air masses is the larger, more dominant one, either the warm or the cold. A stationary front occurs when weather systems stop moving forward, or oscillate back and forth. Near a stationary front, the weather is often gray and dull with precipitation. The precipitation may linger for several days with slight changes in the barometric pressure, wind, cloud, temperature, and dew point. There will be little change and new developments in the upper level airflow to get the weather system moving. And this is the symbol for a stationary front. You can see it takes characteristics of both the cold and warm fronts. Okay, so let's look at some weather maps and reports, basically. So weather reports, NOAA Marine Weather is your best resource. There's also a bunch of apps and websites you can look at. I have a Windy app on my phone. I look at that one all the time for the wind predictions. So let's look at a couple of these weather maps here. Weather maps display various features across a particular area at a particular point in time and use various symbols which all have specific meanings. So we're going to look at some of these symbols here. This is a weather map I took off of the NOAA website for the tropical waters, and you can just kind of quickly glance and see we have low pressure areas, high pressure areas. Here's a cold front, and this would be a stationary front. Cold front down here, stationary front, cold front. There's areas of low pressure, so this L is right here, this L here. High pressure, which is this H right here. Barometric pressure, isobars, are these lines of constant pressure. Here the pressure's 1,009. I zoomed in, if you look to the right here, on an area of that weather map to kind of zoom in on some of the symbols. I have this arrow here pointing to a wind barb, and this wind barb shows the direction is coming from the northeast, because that's, if you look at it like an arrow, that's the way the arrow is shot from. So it's from the northeast, and the barbs on top, or the flags, show 20 knots of wind. So this is 2 full dashes up here. Each one's 10 knots. If you look at this one, my cursor's at here just to the left, we have a 10 knot indicator and a 5 knot. So this is a 15 knot wind barb. You can see the low here. Here is barometric pressure showing 1,009. So that's a low pressure area. Anything below 1,013 is considered low pressure, and large storms or large low pressure areas can get pretty low, like 990 for a hurricane. So remember, lower pressure is a low, and that's normally warm air masses and more unstable weather. All right, some weather forecasting. Use the NOAA online site. Listen to the marine radio, the NOAA weather radio forecasts, and use your apps, Windy app or whatever commercial app you want on your phone to help predict the weather. When you're out on the water, though, you can get some indications of weather. Overall, isolated, wispy, or very high clouds are an indication of fair weather, and crowded, dense, dark, and towering clouds, such as the cumulonimbus, indicate changing or worsening weather. The sharper edge of a thundercloud and the darker its color, the more potential it has for violent weather. So these are just some basic indicators that you can keep an eye out for when you're underway in your boat. Like I said earlier, NOAA has a weather radio. You can get that on your VHF FM radio. You want to check back with that periodically. Go online, get the marine forecast for the area you're operating in, or use one of those commercial websites or apps to provide up-to-date weather observations and predictions. The most important thing to remember is you need to know before you go. You should never take your boat out, especially with passengers for hire, without having a really good idea of what the weather currently is in the area that you're going to operate in, and what the forecast is for at least the time that you're going to be out there. And I usually look a little bit past, just in case I'm out there for longer than I intended to be. So some weather forecasting instruments. One of the primary ones is the barometer, and the barometer is used to measure atmospheric pressure in inches, millimeters of mercury, or millibars. So with the barometer, you need to tap the glass before reading, because the needle will get stuck sometimes. Normal barometric pressure at sea level is 14.7 pounds per square inch, 29.92 inches of mercury, or 1,013 millibars. And what's important about reading a barometer is the rate and direction of atmospheric change. So High pressure usually indicates fair, cool weather, and low pressure, less stable weather, and usually worsening weather. And if it drops quickly, if you check it every half an hour, and you see it dropping, pressure getting much lower quickly, then the quicker it goes and the lower it goes, gives you an indication of how quickly and how bad the weather is going to turn. So it's important that you check your barometer frequently, and you're looking for the rate and the direction of atmospheric change. Lower, worsening weather. If it's increasing, it's usually better weather. So some more instruments for weather forecasting. A thermometer, and this is a picture of a barometer and a thermometer combo. But thermometers are used to measure the temperature, either in degrees Fahrenheit or degrees Celsius. Then we have the hygrometer, which is a wet dry bulb thermometer, and this is used to measure relative humidity. So basically the way this works, you have two mercury thermometers. One is dry and measuring the ambient temperature, and one you submerge the bottom of the bulb in water, and it measures changes in the atmospheric water vapor. The water on the wet bulb causes the temperature to drop, causing it to show a lower temperature than the dry bulb. So they're going to be two different temperatures. Water evaporates from the wet cloth, which lowers the temperature. Relative humidity can be found by subtracting the temperature on the wet bulb thermometer from the temperature on the dry bulb thermometer and using a relative humidity chart to give you an indication of the current relative humidity. Then we have an anemometer, which is used to measure wind speed in knots or miles per hour. So I have a diagram or a picture of one here. This would be the wind speed indicator, and this is a wind vane, and that tells you which direction the wind's blowing from. Remember, with winds, it's always the direction from which it comes. So when I say a northeast wind, the wind is coming out of the northeast. Okay, so there's a neat little law here called Bayes' Ballot Law, and it can help you determine where low pressure is located, and this can assist you in steering your vessel away from the center and right quadrants of hurricanes or other large low pressure systems. So Bayes' Ballot Law states that if you put your face in the wind, so if you turn around so you're facing the wind, low pressure is to your right and slightly behind you, which means if you put your back in the wind, it's to your left. So Bayes' Ballot, if I put my face into the wind, off my right side and slightly behind me is the center of that low. And if necessary, you can use that to kind of give you an idea of which direction you need to run to stay out of the most dangerous parts of the storm, which on these major lows is in the right front quadrants of the large lows and hurricanes. Hopefully you're not out anywhere near a hurricane. You've already checked that weather and knew what the weather was before you went and have found safe harbor somewhere. Lows, including hurricanes, spin counterclockwise and inward in the northern hemisphere. Just to give you an idea of which way that wind's going to be going, depending on where that low, center of that low is positioned in relation to your position. Fog. Fog is a multitude of minute water droplets suspended in the atmosphere, sufficiently dense to scatter light rays and reduce visibility. So fog occurs when the relative humidity is at 100% or the air reaches the dew point. The dew point is the temperature at which air becomes 100% saturated. So the warmer the air, the more water it can hold because it's got like larger molecules, so it can hold more water. The colder the air, the less water it can hold. So the dew point is the temperature point at which the air can hold no more water. And when you're at 100% relative humidity, that means the air can hold no more water and it's going to show as fog. The air is going to be saturated. So we have two types of fog, two basic types of fog. Advection, and this type of fog occurs when warm, moist air moves over colder land or water surfaces. The greater the difference between the air temperature and the underlying surface temperature, the denser the fog. Sunlight hardly affects advection fog. It can occur during either the day or night, and an increase in wind speed or change in direction may disperse advection fog. However, a slight increase in wind actually makes the fog layer a little bit thicker. So if you're going to have wind, you want it to be a significant increase to help get that fog out. Radiation fog occurs mainly at night and early morning with the cooling of the Earth's surface. It clears slowly over water because the land heats and cools 3 times faster from night to day than water. Sunlight burns off radiation fog by warming the air. Surface winds break up the fog by mixing the air. So as a mariner, advection fog is the one that's most dangerous for us because it hangs around the longest and is the hardest to get to clear. Radiation fog is the kind you see in the morning, and then when the sun comes up, it burns it off pretty quick. This concludes our video on weather and our deck video series. Please check our YouTube channel for our other videos.